Welcome back to my chemistry lessons. Today we are going to discuss about the arrangement of electrons in the atom. So as we all know, an atom has a positively charged nucleus. Around that nucleus, there are a number of electrons. So the positive charge of the nucleus is due to the presence of protons inside the nucleus. The nucleus consists of protons and neutrons. And around that nucleus, the electrons are existing. So according to Niels Bohr concept, when an atom absorbs certain amount of energy, the electron present in the atom get excited state or more reactive state. So in the diagram, you can see here, it shows only one electron, that means the hydrogen. Because in all atoms, the number of protons and number of electrons will be same. That's we are called atomic number is number of protons or number of electrons in the atom. So one electron means atomic number one. Atomic number one is a hydrogen atom. So here is a one electron in the first orbit of that atom or first energy level of that atom. So the central part of atom is in positive, that's a nucleus. So when an atom absorbs a certain amount of energy, what happens? The electron moved into next energy level. So we can note this as a E1, the first energy level, and the second energy level is E2. So here also this one is E1 and this is E2. So same here, E1 and E2. So what happens here? When an atom absorbs certain amount of energy, the electron moved into next high energy level. In other way, if an atom released a certain amount of energy, what happens? The electron will back to the original level. So the high energetic state of an atom is called excited state. And the stable form of an atom is called ground state. Ground state. So based on this concept, Niels Bohr made a spectrum with the help of spectrometer. So Niels Bohr got distinct lines on the spectrum, so that indicates different energy levels inside an atom. So these energy levels are occupying the electrons in the atom around the nucleus. So if the energy of higher level of electron is called E2, and the lower energy level is called E1, the energy difference E2 minus E1. E2 minus E1. So here, highest energy level and this lowest energy level, E2 minus E1 is equal to or is proportional to the frequency of light emitted or absorbed. So E2 minus E1 is equal to a constant and F or nu. Some books are saying nu. So E2 minus E1 is equal to HF, or we can call it as a delta E, the change of energy. Difference in energy is equal to HF. So here H is called Planck's constant. Its value is 6.626, 10 to the power of minus 34 joules second is called Planck's constant. So based on this, we are getting an emission spectra or absorption spectra. So these techniques are very useful to identify for the identification of elements, unknown elements, and also the emission spectra is the concept of emission spectra is using in the straight lamps, sodium straight lamps, and also It is also used in fireworks. So see, some of the fireworks are very colorful. So these are based on the emission spectra. And as we go to atomic spectra, that means in that case, absorption of energy takes place. So in absorption spectra, that's also used for the identification of elements and concentration of some elements. And also in water industry, to identify the amount of heavy metals present in the water. So these are the some of the uses of these what you call emission and absorption spectra. So in shortly, I would like to wind up that stressing all these points together, positive charged part of the nucleus, or the central part of the atom, is called the nucleus, and around that nucleus there are certain energy levels, and these energy levels are occupied with electrons. So around the positive charged nucleus, the electrons are rotating. So the holding force electron in certain energy level is the attractive force between the positive and negative charged species. So thank you for watching today. Please subscribe my channel, share my channel. Please stay tuned with me. Thank you.